Let's go ahead and do the homework for tonight. 1.4.2. Number one, it says P or R, not P. Does that entail R? And if you look at it right off the bat, it should be pretty intuitive, right? P or R means at least one of these two things are true. I said one of them is false, so then the other one's got to be true. That seems like it works. So first thing you do, remember, is make your initial list. Your initial list consists of the premises. Premises. P or R, and not P. And you're doing it down here in a row, right? Like going straight up and down. And then the negation of the conclusion. We want to see, is it possible to have the premises be true, but the conclusion be false? So here's my initial list. Not P and not R. There's nothing you can do with those two. The only thing you can do is P or R, and my rule is over here. You split them out. That's because P or R says at least one of these two things are true. Possibly P is true, possibly R is true, so those are my two options. Of course, P and R could both be true, but right here we're just checking to see if either one, either option here is true. We go from the bottom of the branch all the way to the top, so I start with here P, and I see not P, contradiction. That one closes. R, not R, contradiction. That closes. This is valid. All right. Number two says P and Q are, does that mean P and R? And that one also should be fairly intuitive. P and Q means that P is true, Q is true. R, of course, means R is true, so then P and R is just putting these two together. So that should be valid as well. I'll start with my initial list. P and Q are, and then not the case that P and R. Of course, I can't do anything with R, right? That's already done. P and Q, here's my rule right here, the AND rule. It makes sense because A and B means that A is true and B is true. Both of them are true. So there's not two options, there's one option, both of them being true. So I'll write that here, P, Q, check. And then the next one is not the case that P and R, so that's this one right here. That makes sense because A and B says that both of them are true. So if it's not the case that both of them are true, at least one is false. And so these are your two options of which one might be false. Possibly both of them are false, but at least one of them is false. So we split this out, not P here, not R here. Now I look over and say not P, is there any contradictions? Yes, it contradicts with P. Not R, are there any contradictions? Yes, it contradicts with R. Again, this one is valid. Number three. Number three says P or Q and R, not P. That doesn't make sense. Yeah, because this says R is true and this one says not R. So there's already contradiction here. So this already doesn't make any sense. I'm already introducing a contradiction, so nothing should work here. This must have been a mistake. Sorry. Let's see here. P or Q and R, not R, and then my conclusion is not P, so then I have to write not P, which leaves you with P. So, and I check right there. And so then I'm going to apply the AND rule, right? So P or Q is one side, R is the other side, so let's do that. P or Q, shoot, that was not right, sorry about that. This is the AND rule, so that means you write them both, P or Q, R. Now notice right here, I already have a contradiction, right? R and not R. So I really don't have to go any further. I know this is I know this doesn't make sense though, because I've already put in a contradiction here. So really, if I had not P, or if I had P, either one would work. So it's not the case that this is valid. It's just not a good problem. Yeah. So I apologize, guys. Let's go on to number four. Number four says P or Q or R, and the conclusion is R or P or Q. And intuitively, this should make sense because all you're saying here, let's indicate that conclusion. All you're saying here is at least at least one of these two things are true, R or P or Q. And P or Q is saying at least one of these two things are true, P or Q. So in all of that, you're saying at least P, Q, or R, one of those three things are true. And that's what this says too. So this should make sense. All right, first off, I'll apply the not R rule, because this is, again, right here, this is A, here's an OR, and this is B, and there's a not in front of it, right? So it's not A or B right there, just like that. So it'll look like so. Oh, so here's the not OR rule right here. Not the case that at least one of these two things is true, so both of them have to be false. So not R or P, and not Q. And again, I'm going to have to apply another not or rule. So this one's check. So not R, not P, check. Now I'll have to do some ORs. So P or Q, R. And the OR rule is over here, right? At least one of these two things are true. So my options are on this side, P or Q being true, on this side, R being true, and then check up there. And once again, at least one of these things are true, P, possibly Q, check. I look up from the bottom, and P contradicts with not P, so this is crossed out. Q contradicts with not Q, that's crossed out. R contradicts not R, this is valid again. I think the one before this was supposed to be invalid, and I think I think it was supposed to be P or Q or R, not R. Does that entail not P? And that would be invalid because Q is a possibility. But I had a typo, so all right, last one. If P, then Q or R. Not the case that not Q or R. Now notice what this one is saying, by the way. It's not the case that either not Q is true or R is true. It's not the case that at least one of these two things are true. So both of them are going to be false, right? So Q is actually going to be true. Because if not Q is false, not Q says that Q is false, then Q's have to be true. And then my conclusion is not P. So I'm going to have to write not P. Because that, I got to negate the conclusion. Alright. Let's see here. Not rule is the easy one, so I'll do that one first. Not turns into regular one. The not or rule is right here. I want to use that one next. So now, not Q or R. Not Q is my A. R is my B. So I'm going to say not Q, not R, check. And not Q turns into Q by the not rule over here. Then my last thing I have, my last formula in the initial list, I have if P then Q or R. Now A is if P then Q and B is R. So I'm going to use my OR rule, which says to split them out. And I'm going to write on this side if P then Q, and on this side R. Oh no, check that because I did it. And now I'm going to use my if then rule right here, right? And it says not P, Q, check. Start here, not P contradicts P, cross that out. Q does not contradict anything. Here's another Q, doesn't contradict anything. Not R doesn't contradict anything. P doesn't contradict anything. This is an open branch. Again, I can stop there and just say it's invalid and work from there. I see this other branch over here. If I'd like to, I could check it, but it doesn't really do anything for me. I can do it really quickly though. R contradicts not R, right? So that branch closes. But at least one of these things is closed, is open. Excuse me. So that means we're going to have at least, and this is the one. This is the branch I'm going to use. At least one branch. That means it's invalid. And now I'm going to do the counter model. Alright, so let's do the counter model. The first, I have a P up here. You may have noticed I'm doing like in alphabetical order. It doesn't really matter how you do your counter model. I don't know why I do it that way. I don't know. I have problems. So, truth value of P equals 1. Truth value of Q equals 1. Because I see I have on this branch Q. Notice I have a not Q here. It doesn't mean Q is false, it actually means Q is true, right? That's how we got this. So Q is true, and then I have not R on this branch. So the truth value of R equals 0. Again, if you see that you have one of these propositional parameters, P, Q, or R, if you see one of these you have equals 1 and somewhere else you found equals 0, what that means is that you didn't cross out that branch. You should have crossed out that branch because there's a contradiction in that branch. So there's no way you should have like P equals 1 and P equals 0. You'll never have that. All right, and very briefly, let me read back into here what this means. All right, so what this is saying is if because we did the contradiction of the conclusion here. We said not P, right? And we took the regular premises up here. So what this says is if you have the premises and you can have the conclusion false when, looking down here, P is true, Q is true, and R is false. So let's see what that says. If P, then Q or R. So like something like if you have spaghetti and meatballs, then you have pasta, or it's the case that you just had fish, right? It's not the case that you did not either you did not have spaghetti and meatballs. What was it? I don't remember what I said. That spaghetti and meatballs is pasta? No. If you have spaghetti and meatballs, then you have pasta. Okay, so yeah, it's not the case that either you do not have pasta or you have fish. Does that entail that you do not have pasta? See how just crazy it is, and we wouldn't be able to figure this out without logic. So yeah, when it's the case that you do have spaghetti and meatballs and you do have pasta, right? But you don't have fish. All right, that's what this one says. All right, so that makes this premise true because over here you do have spaghetti and meatballs and you do have pasta. You don't have fish, but at least one of these two things are true, and that makes the whole thing true because it's an or statement. And over here, it's not the case that at least one of these two things are true. That's what this one says. So it's not the case that the first one says that you did not have pasta, right? But you did have pasta, right? So that one is, it is the case that this one is false. And it's not the case that you had fish, right? So not fish. So that one makes sense. This premise is true. But what about P equals 1 is, let's see, what is that? You had spaghetti and meatballs, right? So it's not the case that you have spaghetti and meatballs. Is it possible? Yeah, well here you did have spaghetti and meatballs, right? So that's the contradiction of the conclusion. So you have these premises true and the opposite of the conclusion is true, or the conclusion is false in other words. So this does not prove the conclusion. All right, and that's the homework.